Hi everyone. For 5th grade lesson 3 for our Elevate groups, students will be working on adding and subtracting fractions, specifically with like denominators. Now, because the denominators are like, students will know that they need to keep the same denominator, but only focus on adding and subtracting the numerators. So, in this example right here, we know that our unit is eighths, so our denominator will stay as eighths, and we would only focus on adding, in this case, the numerators. 1 plus 2 is 3. Students will get that right. Now, I'm pretty sure that students have probably had some wins with this particular skill in the past. So, what you'll find is students will generally breeze through this particular lesson, which is perfect because they have even more time to work on iReady on this particular day. However, we want to spend a bulk of our time making sure that students master how to simplify our fractions once we add or subtract. Um, and so in this example right here, we'll do the same thing that we did in this example, right? Keeping the denominators the same and then subtracting the numerators. So 5 minus 1 equals 4/8. That is the answer. However, it's not the simplified answer, right? So what you want to ask students during your model and even when they're struggling throughout the lesson is, what greatest common factor can we use to divide both the numerator and the denominator? Well, I think the first question you want to ask them for any question is this answer simplified, right? So students will say in the first example, yes, it is simplified because there's no factor that can go into 3 or 8. However, when you ask them, is 4/8 simplified, students will say no, because it can be divisible by 2, it can be divisible by 4. Some might even say it can be divisible by 1. We're not using 1. But it can be divisible by 2 and it can be divisible by 4. So we want to ask them, well, which one of those is the greatest common factor, right? Because 4 is greater than 2, we are going to use 4 to divide both our numerator and our denominator, leaving us with 1/2. And so you'll spend about, again, because kids probably will do great on this skill, and the first 4 questions don't require them to simplify at all, have them work through it. They'll experience probably 0 errors. However, while you launch them into their partner practice or independent work time, you want to make sure that questions like 5 and even 7, see, this question right here hasn't been simplified, but this should be 1/2. You want to make sure that questions like 5 and 7 are being simplified as you're circulating. So asking those 2 specific questions, hey, has it been simplified? Yes or no? If no, what greatest common factor can we use to divide both the numerator and the denominator? Again, you want to highlight 9. You might even want to model this question at the beginning of the lesson so students can see how you target a question that needs to be simplified before they launch into their independent practice or their work time. And then, of course, we have a 5-minute exit ticket for this lesson. Students will get 1 point for their simplification, for their original answer. So when you add question 13, you get 2 out of 2. But then they'll also get a point for simplifying. Same thing for question 14. And then because questions 15 and 16 do not need to be simplified, they'll just get 1 point each for those questions, totaling to 6 points for the entire exit ticket. And here is the scale.